Hello everybody, I'm Nick, and in this video we're going to do something different. In this video we're going to take you with me in a journey trying to figure out what's the easiest way and the most straightforward way in creating our own dependency injection container. Now, why would you do that? Every language pretty much has one. Well, the reason is simple. I'm curious to know how they work and I want to see if I'm actually able to implement one. And we're going to go just for functionality. We don't care about performance or optimizations. I want to see if I can take what I know just by using dependency injection containers and create one on my own. So as you can see, I have a .NET Core 3 application. Now, no dependencies, no nothing, no IoC, no dependency injection. I'm gonna go ahead and start developing based on what I think I need. So the first thing I definitely need is a new directory, and I'm gonna name that dependency injection. And just to sort of have a feel for what we're trying to do here, I think I need a way to register my dependencies when the application is starting, and then I probably need a way to resolve them as well. And the other thing I need is resolve services as they're being required by constructors. So let's see how I can do that. The first thing I will probably need is some sort of container, probably. Let's see, var container equals some, I don't know, new di container. Probably, and then I would have something like container.get service and then service name. Yeah, and then that's how I would get a service. And then I also probably need some sort of collection, so I don't know, services, where I can have a new di service collection. I think that's how .NET sort of does it. It has a collection and then it has the container or the provider. And what I'd want to do is register Singleton and then provide the implementation type. So I think that's how I kind of want it to look like. And then I want to be able to also register transient lifetimes. So let me just talk you through what you're seeing right now. We should have some sort of collection where we are able to register our dependencies and sort of specify the lifecycle as well and the implementation. And then I want to be able to say, I want this service to be registered as a singleton. A singleton is an object that's only been initialized once in the whole application's lifetime. A transient is a class that's being instantiated every single time you're calling this service to be resolved. So I'm probably going to have service 1 and service 2, and same thing here. And I think that's sort of how I want it to look like. So let's go ahead and create this service collection first. So di service collection. And let's give it that those methods I was talking about. So let's just make a new class, and that's gonna be, I don't know, random GUID generator. I'm not gonna care about interfaces in the beginning. I'm just gonna use that. So I'm gonna say prop GUID, and then I'm gonna say random GUID, and the default for that will be a new GUID. So essentially a class that when you call this random GUID, it will give you a random GUID, simple as that. And I'm gonna say a random GUID generator, so register that as a singleton, and let's remove that for now. Okay, and then I'll probably need that method, but let's just leave it unimplemented for now. Now the other thing I need is a di container, and I don't think that I'll be creating this container like this. I think the container will ultimately be created by the services. So I'd have something like var container equals services dot generate container or build container, something like that. And then this returns a di container. So what I'm going to do here is I'm going to create another di container. Yeah, I sort of like that. So let's just remove that. And I'm going to create this method as well. And I'm going to say this returns a di container. Yeah, that feels about right. And then the container needs the get service method, which is where we're resolving the service from the container. So if I go in here, I can make actually I can just generate it like this. So this should be the service itself, and then you're getting the service. Yeah, you know what? I think that looks right. So register the singleton, generate the container, get the service back. And then I'm gonna do the following. I'm gonna say console write line service.random GUID, and then I'm also gonna say random GUID again. And no, that won't do what I want. Service first, service second. So I'm getting it twice from the container, but because it's registered as a singleton, it should return the exact same reference to this class, which means the GUID I should get should be exactly the same. So I think that makes sense. Now I need to implement the register singleton class or method, but I need some other stuff here. So I need a way to describe my services, what I'm registering essentially. So I think I'm gonna need another class, and I'm gonna name that service descriptor. I think that's the right word. And what I need is probably the service type. And then I also need to store the implementation. Because what happens if you do the following? What happens if you do... Okay, that's one way to register a singleton, but you should also be able to register a singleton like this. Or any service for that matter. You should be able to provide the implementation you want to be returned. So let's do that first. I'm gonna say register singleton. And I'm gonna remove that from here. Or okay, I need it. T implementation, or actually T service, and then implementation. And then I need to store that somewhere. Okay, so in the service descriptor, I'll probably gonna have a private list. Should it be private? Yeah, why not? A private list of service descriptors. So service descriptors equals a new list. Let's default it to something. And in there, I want to add this, and I want to say service descriptors dot add new service descriptor, and I'm probably gonna just provide the implementation. Oh, and I also need to provide the lifetime. So let's make a new enum here. Yeah, service lifetime. And I'm only gonna have singleton and transient. Yeah, that looks right. So let's say I want this implementation, and I want this as service lifetime dot singleton. Right, I think we're onto something. So let's create. I don't think these should have public setters. This should have private setters. So let's say we have an object, which is the implementation. And then let's say we have the lifetime. Yep. And then I can just say type equals implementation dot get type. And then implementation equals implementation. And then I can also say prop service lifetime and remove the setter, and I have the lifetime. Okay, so I think that's let's rename this to service type. Yeah, I think that looks pretty good. So let's go back to the service DI collection, and now I can see that I can register my singleton, which looks good. And then I have my generate container method, which will need to return a new DI container. And probably the container needs to get all the service descriptors and do something with them. So let's make a constructor that has that, a list of service descriptors. And then, should we just store it as it is? Yeah, why not? Private list of service descriptors. Yeah, it looks fine. And then say service descriptors equals. Okay. So now I have my container. The question is, what's the difference between the collection and the container if they both store this list of stuff? And also, this should probably be mutable, this list, but I'm gonna keep it as it is for now. Let's close that. And then what I want is to be able to get my list back, or my service back. So I'm probably gonna have to find the right descriptor in the get service method. And I'm gonna do singular default. Okay, let's do a new line so we can see what we're doing. and then I want my service type to equal the type of T. T is the type that's specified in the generic here, and then we're checking for the descriptor, and if the descriptor dot implementation is not null, then return it. Now this is saying this could be null, so if I say if descriptor equals null, then we're gonna just throw a new exception. We don't want to do anything at this point. Service, let's give it a friendly name, service of type of T, whoops, name isn't registered. Okay, so if the service hasn't been registered, we're just gonna say boom, there's nothing I can do. You could probably return null instead of blowing up, but I think this is gonna make debugging easier, so I'm gonna leave that there for now. So if the implementation isn't null, then descriptor.implementation return that. We're probably gonna have to hard cast it to the T. Yeah. And then return null. This is not nullable though. Oh, null of T, so return default. Okay. Is that enough to return a singleton? So we're not really using this. Let me just remove this for now. You know what? I'm gonna go ahead and I'm gonna run this and see what I'm getting back. So I should get the same GUID twice. That's what I want to see. Okay, so let's debug this and see what's going on. I did get what I wanted, the same GUID twice, which is awesome. So our service has one service descriptor with a lifetime of singleton, the service type that I want, and then implementation. Okay, cool. Now I generate the container, and it's sort of the same thing. Again, a bunch of service descriptors, but that allows me to get services out of it, which is good. And then I can get the same service from the container twice. So if I run this, I should see the same GUID twice. Where did that go? I don't know. Oh, the console is gone because I stopped. That's fine. So, okay, that works if I provide the implementation. But what if I want to say, just take the class, register it, potentially instantiate it as well automatically. So sort of what a more modern DI container would do as a singleton. So that's where I'm going to create that new class. Yeah, that makes sense. At least to me. I'm going to remove that. So T service, get that, and potentially just say type of T service as a singleton. So register the descriptor. Now I probably won't add any checks if it's already been registered, at least for now, and I might want to do that later. So register singleton, I register the type. The type should not be the implementation, so I need a new constructor here in the service descriptor. I need to be able to say type and then service type and lifetime, but don't provide the implementation because we don't actually have an implementation. We're going to do that when we call the service, and hopefully only once. So service type, and we don't need the get type. Does this make sense? I think it does. So what we have here is we just register the type and the lifetime, but we have no implementation. Okay, and then in my DI container, when I get service, I can say if implementation is not null, return the implementation, fine. So at this point, implementation will definitely be null because we checked already for that. So we can actually say, can I use activator here? I think I can actually use activator. Activator is a class in C# that allows you to create an instance of a class dynamically just by using the type. So I should be able to say descriptor.service type. And because I have a parameterless constructor, this should work. And I can probably also say of type T. No. Okay, no. Well, at least I tried. I should be able to say T though. So if I go back to my program, I no longer provide the implementation. I just say register this as a singleton, and just instantiate it once. So if I run this, I should still get the same. Ooh, that didn't work. The Singleton was registered twice, or I got the value twice? Why is that? Oh, because I created it twice. Okay, now we're getting somewhere. So the implementation is that now. So I could say descriptor dot implementation equals implementation here. Now I'm not able to do that because the setter is private. But what if I said, there's actually two ways to go about this. I'm gonna go the hacky way first, because I'm just testing things out, and if I have time, I might just investigate another option. So at this point, I can say return the implementation. And the next time this comes in, the implementation will be null, and I'm gonna get the same. Let's see if that actually works. Okay, so the Singleton one is also working. Cool. Okay, now I want something else. Well, in fact, I need a check here, because I only want this to happen if this is a Singleton. So if descriptor dot lifetime equals Singleton, okay, then return. Okay, cool. That makes more sense, because now what I'm going to do is I'm going to register something as a transient. And yes, this only makes sense to do with the generic type. I mean, I could do it without the generic type as well. Register transient. And as we said, transient is something that you instantiate every single time you call the get service. Nothing will change here except for the lifetime. So if I do that, and I remove the register Singleton for a sec, or I just delete this, comment this out, and say register transient, then I should see two different GUIDs when I run this. Because I'm getting the service twice, it's transient, so it's instantiated every single time. Okay, cool. So we're done with the get service and the register transient and register Singleton for now. Now, you know what's actually pretty difficult? Let's go ahead and create an interface. So a more realistic scenario. So I'm gonna say some service, and this service will public in an interface. What am I doing? And this service will return a void print something. I mean, the simplest thing you can do. And then I'm going to implement that service. And I'm going to say some service 1, because we might do this many times. So some service call, and then private read-only GUID random. So sort of the same thing, but instead of returning something, we're going to print this. Console.WriteLine random GUID. Okay, so now we have an interface and we have a class implementation. And what I want to do is I want to be able to register them like this. I want to be able to say services.register transient some service, comma, some service 1, because that's also a thing you see very regularly, and that's what makes our application testable, is you having an interface in your application to inject through the constructor, and then you provide a mock to actually test that around. What I'm going to do now is I'm going to register this service, and I might make this a bit more complicated in a bit, but for now I'm going to separate this to two methods. First, provide the service, which is the implementation, and then let's create another method which has the tService, tImplementation. Is that what I want? That is what I want. So now when you use the interface, you get the class back. This complicates things a little bit, but let's just see how we can get this to work. I need to say type of the implementation here, definitely. And I need to make that interface, that constructor, sorry, as well. So I need to say the service type and then type implementation type. Then I probably need to store this here as well as a property. So I had service type. Now I'm gonna say implementation type. Okay, that works. And I'm gonna say implementation type equals the implementation type coming in. Okay, I think I'm onto something. So now I go here and I say descriptor, singular default, by service type, which is fine. If the descriptor doesn't exist, throw, okay. If the implementation is not null, return the implementation. Now, if the descriptor dot implementation type is not null, then you want to instantiate the implementation type. Okay, that gets a bit more complicated. So, actually, is it? Can I do this in some dirty smart way? Description dot implementation type. Does this make sense? Activator, create instance. Try to create the implementation type instance if it exists. If it doesn't, try to instantiate the service type. If it's a singleton, save it. If not, return it. Does this, will this work? I'm very curious. Okay, so now I want to change these with the ISAM service, and I want to call the print something method. And I don't actually need to double print because that's a void. So I'm going to say first service, and then I'm going to say second service. Let's run this. If I've done this correctly, I should see two different GUIDs being printed. Okay, cool. So this worked. I have a way now to say, give me this interface, but you actually get the implementation of this interface, which is this service. Okay, I'm onto something. Now, it will get harder if I actually have constructors here. So what would happen if I have a constructor like this? And then I didn't have this random GUID here. Instead, I had a private read-only random GUID provider. And then I named this random GUID provider. So what if I had this interface? Let me just paste this here and comment it out. So I'm gonna go ahead and create that. That's an interface, a random GUID provider, and then this returns a random GUID. Okay, and because I don't want to create a million files, let's create the implementation here as well. So random GUID provider, create implementation, and just implement the interface and default it to a new GUID. I'm using GUIDs because it's the easiest way to show the difference between something with a specific value and something without that value. There's no other reason why I'm doing it. So okay, now we have this random GUID provider, so I can close this. And we're injecting it. So now when I inject through the constructor, which is what you would normally do if you were using dependency injection. And then this provider will give me the random GUID. So I think I have to use a reflection here. I have to sort of see the dependencies as a graph, because the way this works is you have the top node, which is the entry service, and then this service has dependencies and the dependencies have dependencies. So I need to traverse that. And instantiate as I go. Now, I won't do anything fancy. I'm probably gonna use the simplest way to do that. And it might look hacky, but I think it will work. So, what I want to do at this point is get the descriptor. Okay. If the descriptor is null, okay, it happens. If the implementation is not null, return it. Okay. So this is where it all comes into. Okay, so I need to extract this as a separate type. So I'm gonna name it actual type. It's the one you're gonna instantiate. So var actual type equals other implementation of service type. Now, if at any point is abstract or actual type is interface. Obviously this cannot be instantiated, so I will need to just throw here. So throw new exception, cannot instantiate, I think this is correct, abstract classes or interfaces. Okay, now what I want to do is I want to get the constructor, and ideally in that scenario you'd want to have a constructor where you have ways to provide the types that it requires. I probably won't do that because that will be a bit complicated for this video, but what I can definitely do is say construct, I think it's constructor info, let me just see, actual type dot get constructors. Okay, and then I can do, oh, you know what, I'm just going to do first. So get the first available constructor, and everything should have a constructor. Now, if it doesn't have one, you cannot instantiate it, so this will throw there. So var constructor info equals that. Okay, then I need to get the parameters of the constructor, because I need to essentially, in this example, need to get this, or if it had many, and this, and this, and this, and provide an implementation for that from my DI container, because remember, we don't actually provide them, we inject them. So let's see if I can get, well, how we can do this. Constructor info dot parameters, get parameters, okay, and then let's select, so X is the parameter, and let me see how this will actually look like, because I think I have an idea. The activator, there's two ways to do this. The activator allows me to provide an array of objects, which is the arguments, where the first item in the array is the first parameter of the class. So the 0 index in this array would be the I random good provider, which means that if I say, I might need to create a new class here. So I'll change this a little bit. I'm gonna say public object get service, and then I'm gonna say type service type, and then everything in this get service with the generics method will be removed and pasted here, and anywhere I do get type of, I will use this, and this will just return the object. Same here. Okay, and now this method will do return hardcast the T and say get service type of T. Rider hates me because it deleted my stuff. Okay, so same thing, but now I have the type, which means I can say parameters, and the parameters, oh, this will be so cool. Oh wow, okay, so the parameters will be instantiated with the get service method. So I can say get service and use recursion here to get the parameter type, and then if I say to array, this will return an array of objects, but the objects are the instantiated services. Does this make sense? I think it does. So if I do that, now I should have everything I need. Let's just try it out. So I have a program, register the service. This service requires a random GUID provider, and this isn't registered, so I'm also going to register that. Services.register, let's say Singleton for now, and we're going to do a Singleton as well. Let's say Singleton transient. Our random GUID provider, random GUID generator. I think it does. So let's run this. If I'm not able to instantiate it, it should throw an exception. Okay. I'm not able to instantiate it, and it throws an exception. We are gonna get somewhere. So missing method exception. Okay, why are we getting that? I know that you can, interesting. Actual type is this. We get the first constructor, we get the parameters for the constructor, we instantiate them, and then we're returning them. What if I say constructor info.invoke parameters? Will that work? Huh? I don't know. This is weird. It should have worked, I think. Okay, same thing. Argument exception. Am I inheriting? Random GUI generator is the wrong name. Damn. Okay, so damn, it was working. I need to fix this. In here, okay, so this was fine. I can just remove that. And if I now use the right implementation, I wonder, is there a way to do a compile time check? Because that's not great. Hello everybody, Nick from the future. You can actually do that by going into the method you want to add the restriction, say where the implementation implements or extends the service. And if you do that, then you can go in the program and see that, hey, this needs to actually implement or extend that. So a random GUID generator won't be accepted, but a random GUID provider will be accepted. Back to the video. Okay, provider. So how about that? Will that work? Okay, and that works, and the GUIDs are different. I know they start the same, but because they were generated so close to each other, they have the same first number. Right, so this is working, and that's a bummer because it would work in the first try, which is a first for me. What happens if I register that as a singleton? So same thing as a singleton. I should see the same GUID twice, so the same implementation should be used twice. Of course, I don't have the same singleton approach here generated, so I'm gonna go ahead and add it here. So register singleton, and then I need to change this to singleton, and then if I run this, same GUID. Okay, so that means I actually have a functional DI container, because you can register all your services in the DI service collection, then you can generate the container out of it, and as long as, let's say you have a main service, so let's say main app here, and you have a public async task, I don't know, start async, what you would normally have in such an application. As long as you do something like services.register singleton main app here, and then whoops, you say main app, and then you comment that out to make it clear, not deleted, comment out, cool. And as long as you say main app dot start async, potentially awaited, I'll need to change this to an async task. Yeah, this should work, because now everything in that main app and downstream will be traversed properly and generated. It's gonna use reflection, so it's gonna be slow. You can potentially speed that up by caching things. But I think we have a very high level POC of a DI container. That's all I want to do for this video. I'm gonna upload this code on GitHub, and I'm gonna give it to you if you wanna play around with it and see how far you can get. Make sure you raise a PR if you have an idea. I found this very, very fun. I want to do other things like this, where things we take for granted, I want to try and code them from scratch to see what they look like. So I hope you enjoyed this video. Leave a like if you like, subscribe for more content like this, ring the bell as well, and I'll see you in the next video. Keep coding.